In this video, I am going to explain what is divergence and its geometrical interpretation. Last class, we saw the operator del. Now, del dot v vector. It's a vector function. Last class, gradient of temperature T. So, it is a scalar. Now, this is a vector. So, we have taken the dot product. This operator is a vector. Del is x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. Then this v is a vector function. Dot can be velocity v vector. So it is three-dimensional. Vx x cap plus vy y cap plus vz z cap. So this is a vector. You have to take the dot product. So when you take the dot product, x cap dot x cap is 1. So it is dou vx by dou x. Similarly here, y cap dot y cap is 1. So dou vy by dou y plus dou vz by dou z. So you can see here there is no x cap, y cap, z cap. So what you are getting is a scalar quantity. So divergence of a vector is a scalar. So this name is a well chosen. The reason divergence of a vector function gives how the quantity is diverging from a particular point, how it is spreading or how it is diverging from a particular point. For example, here you can see it is diverging from a point. So it has got a positive divergence. Suppose the arrow is directed inward, then it will have negative divergence. So here it is positive divergence. In this case also it is positive. Divergence is positive. So you can see the length of the arrow is going on increasing. So it's a positive divergence. But for this it is zero divergence because the length of the arrow same. There is no divergence. In this case, zero divergence. Here in these two cases, positive divergence. In this case, negative divergence. To understand that in a better way, you consider you are standing at the edge of a pond, at the end of a pond, and you drop some sawdust. If it is spreading, if it spreads out, then it has got positive divergence. If it is collected together, it is at a point it is negative divergence. Anyhow, it is in this case v is the velocity vector, velocity of the water. But anyhow, it is in two-dimensional, not three-dimensional. It is two-dimensional. Anyhow, to understand the concept of divergence, you can depend on this two-dimensional model idea. So it is velocity vector. So how it is spreading? If you are dropping sawdust, if it spreads out, positive divergence. If it is collected together, it is at a point negative divergence. Now, suppose the vector function representing this is given. V vector is equal to x cap plus y cap plus z cap. So this vector function is here. Now divergence, this is the divergence. So now in the place of Vx, now x is there. So for this Vx you can write x, Vy, that is y, then Vz, that is z. So here this is the vector function. So instead of this we can write here this. So instead of Vx it will be x. So dou x by dou x it is 1 plus dou y by dou y 1, dou z by dou z 1. So 1 plus 1 plus 1, it's 3. So as anticipated, it's a positive divergence. So divergence is 3. See, it's a scalar quantity. Divergence of a vector is a scalar quantity. Gradient of a scalar is a vector, but divergence of a vector quantity is a scalar. Now let us find the divergence for this figure. So it is represented by this vector function is z cap. That means there is no component along the x, y, there is no x, y components. Then this vz is 1. Vx is not there, Vy is not there, it's 0. So now z cap. So now in the place of Vz, what is there is 1. So it is fixed, it's a constant. So if you put here, only here it's there. So del dot V vector is equal to, here Vx is not there, Vy is not there, only this z cap. So that is, here Vz is 1. So dou 1 by dou z. It's a constant. Differential of a constant is 0. So in this case, divergence is 0. In this case, vector function is z cap. So here Vx, Vy, it is 0. So in this, if you substitute here Vx 0, Vy 0, so these two terms not there, then in this, instead of Vz, now it is z is there. So you put for this Vz, z. So dou z by dou z is equal to 1. So in this case also the positive divergence. I hope you have understood the concept of divergence, and thank you for watching the video.